Hi, Assalamualaikum warahmatullahi wabarakatuh to viewers. Right, thank you for watching my presentation. Okay, so today I'm going to present about my titles, which is automatic climate control for mushroom cultivation using IoT approach. And this research is being done by me, Muhammad Azizi bin Muhammad Ariffin, and my other colleagues from National Autism Resource Center. We are located at FSAM UiTM Shah. Okay. Right. So a bit of background about our research, right? So according to Anderson, climate change which occur in the world today has threatened food security globally, right? Because cause of climate change, the agriculture yield decreasing, so we have a challenge in increasing food production. Um, during climate change. And one of the way to tackle the challenge of food security is by um, implementing urban farming, right? So according to Othman, urban farming is seen as sustainable practice with the social, economic, and urban environment benefits, right? Because nowadays we can see that most of the world population is living at the city, so all the unused space at building, high-rise buildings can be utilized for urban farming, right? So when we look at the current farming practice, right? So it is tedious, right? Time consuming as farmers need to manually water the plant and check its growing condition. So we can see from the conventional practices. So let's say we are planting, for examples, cabbage, right? So you need to manually water the cabbage, right? So spray pesticides, right? So it's quite labor intensive. So if you are only do your personal farming, it may be not time consuming, but if it's um, being planned with thousand of acres or hundred of acres, so it will take a lot of labor to do that, right? So that's why with the advance of internet of thing technology, it seen as a potential to act as a catalyst which can increase the yield and efficiency of urban farming, right? So in the context of this research, we are looking into a mushroom, oyster mushroom specifically, right? So why we seeing a mushroom? Because it is suitable for urban farming as it takes up small space, doesn't require direct sunlight, and takes a shorter time to harvest, right? And it is also sustainable and environmentally friendly, right? So nowadays, oyster mushroom have a lot of demand, and it can be cultivated in a indoor space. So it is very suitable for urban farming. Okay. Right. So what's the problem with current oyster mushroom practice, right? So in order for the mushroom to have uh, produce high, in order for us to produce high quality with high quantity, right? So if we want to have the optimal growing condition, the mushroom must uh, be growing in a condition of temperature ranging between 22 to 28 Celsius and humidity of 70 to 90%. Okay, so usually in order to regulate the temperature, um, conventional farmers will either spray the floor or the wall of the mushroom house so that it want to regulate the temperature. So for example, if that day the temperature outside is very warm, for example, 30 degrees. So they usually will spray the floor with water, right? And the process is the man. So when you monitor the temperature and humidity manually, it is very cumbersome and time consuming, right? So again, you need a lot of labor to do that, right? So it's a problem. Okay. So, when we done our literature review, right, when see several related works, so we find several articles which also looking into this problem. Okay, so we have the work which they use IoT system, okay, to monitor air temperature, air humidity, and soil moisture of oyster mushroom cultivation in an indoor space. But for that, they haven't tested the system on the real mushroom cultivation. They are either build a prototype and they do their modeling, or they do some simulation. So not in the real world examples. So also there is a work which they consider the temperature, light intensity, CO2 levels, okay, and so their works, based on their result, they're able to optimize the usage of resources and maximize the quality and productivity of the mushroom. But the implementation of using their approach is the additional parameters requires complex requirements and a logical design that increase the initial setup costs and maintenance costs. Also, there are quite sophisticated approach which they use extreme learning machine approach, right? So they utilize a machine learning to monitor humidity and temperature in the cultivation of oyster mushroom. And so far, based on their results, they only simulated this on MATLAB, right? But when you use all these computational intensive approach, you need a high-end microcontroller or CPUs, right? So this will rise the cost of implementation and also the maintenance cost of the system. So far, when we see there is a gap there, right? So far there is no immersion, no work has been done to test on the real world scenario, on the real mushroom house, right? And so what we propose in this project. So this paper propose an automatic IoT-based climate control system at minimal cost, right? So the system is very simple, very minimal. It only takes up around 500 to implement the system, and it has been tested to work in the actual setting of oyster mushroom cultivation. So there is a mushroom house which they do it manually, and we enhance the mushroom house with our system, with the IoT system, and we can see that it's improved the yield and productivity of the mushroom house. Okay, so we will look into the system design, system operation, and results of the implementation. Okay, so for the system design, right? So this is a top view of the system. So we have a mushroom house, right? So the mushroom house here is being surrounded by a netting, right? So this is the existing. So inside the mushroom house, there is around 11 rack, right? So the rack will store or hold the mushroom bag, right, where the growing medium of the mushroom. Okay, so here we install two temperature and humidity sensor, right? We're using the HT32 sensors, and it will be connected to the IoT control box. So simply the IoT control box contains the microcontroller, right? ESP8266, right? So it will control the growing condition based on an algorithm, which we will discuss later on. So um, based on the decision made by the microcontroller, it will regulate the climates or the environments of the mushroom house, right, by turning on water pump or turning off the water pump, so that when the temperature is high, so it will spray the floor and netting of the mushroom house. And also we have an exhaust fan which will control the temperature and also the humidity. And also since this we are using 8266 microcontroller, so it can be connected to Wi-Fi, and we have an internet gateway which we connect to the internet, and the whole system can be monitored by using a smartphone or computer from anywhere with internet connection. Okay. So this is the schematic of the IoT control box. So at the heart of it is 8266 microcontroller, right? So as an input, it receive a temperature and humidity as values from DHT22 sensors, which we place on the ceiling. And as an output, right? So we have a relay 5-volt relay which will control water pump and also exhaust fan. It also have a LCD display which display the current status of the system, whether it's running program 1, program 2, what it has been doing, the system uptime, and it is connected to the internet gateway, so it can have internet connectivity, and it has a web interface so that we can know what is happening on the system, whether what is the current temperature and what program is currently running, whether the pump is currently on or off, the system uptime. Okay, so this is the system schematic diagram. Okay, so this is the system web interface. So from here we can know the temperature, the uptime, and if the water pump is running, it will show that currently water pump is running. Okay. Okay, so the microcontroller, how it's regulate the temperature, right? How it's process the temperature and humidity is based on this algorithm which we set. So first, at the start of the operation, before the sensors take up any reading, it will first wait for 5 seconds, right? Because DST22 is a quite slow sensor. So in order for us to avoid getting a null result, so the system wait first for 5 seconds, then it will read the reading from the DST, the sensors, right? So if let's say we are getting a null results reading, maybe because of crosstalk or sensor is not functioning well, is will repeat back to the first step, right? So and because we, in order for the system to proceed, is must be able to read the humidity and um, temperature values. So when both sensors provide humidity and temperature values, it will calculate the average temperature and humidity, and it will display the values at the LCD display and also to the serial port. Right. So the way is in this algorithm, there is basically 3 programs, right? So the first program, it will check the average temperature. So if the temperature is more than 27 Celsius, it will start a counter and it will on a water pump for 20 seconds. Then it will turn off the water pump, and after that it will then um, start the exhaust fan, right? Okay, so then it will go to the next flowchart. So it will go to the second program. Oh, by the way, when the program 1 start, the program counter will become 1. Program 1 status will become 1. So because why we need that? Because when it goes to the second program, so it will check if the average humidity is more than 80, right? And also the program count is less than 4, right? So it will on an exhaust fan in order to reduce the humidity, because for mushroom, uh, when the humidity is high, it will destroy or the mushroom um, cultivation process, right? So because there will be higher chance of bacterial infection if the humidity is too high. Okay, so it has a counter, so we can track how many times the program has is running. And next, it will go to program 3. So for program 3, it will check if the humidity is less than 60, so the environment is too dry, so it will also start its counter, and it will open up a water pump so that the humidity level can be increased. Okay, so while when the program is running, it will also send a signal to LCD display and also to the web interface to show that the program is currently running. So next, okay, before it return to start, it will check. So if let's say the system check that the program has been either three of the program has been running for more than 3 times. So if it's running for more than 3 times, it will go to the sub program, which it will stop or wait for 2 hours. So this is why, because we want to avoid waste of water resources and electrical resources. So for examples, in some scenarios, in the environment or is too hot. So let's say the temperature exceed 30 Celsius, right? Or 32 degrees Celsius. So even though the program keep trying to sprinkle the water or increase the humidity, it can only reduce the temperature, let's say 2 degrees Celsius. So if we doesn't have this stop program, it will continue to sprinkle water non-stop, right? So it will waste the water. So that's why we need a stop program. So at the end of it, it will return back to start. Okay. So this is the overall system operation flowchart. Okay. Right. So this is some pictures from the implementation. So this is on the left on figure 5, we can see the rack which store the mushroom. So this is the mushroom bag, right, containing the growing medium for the mushroom, right, and you can see that the floor is wet because the system is sprinkling the water to the floor, right, and it doesn't sprinkle directly because when the oyster mushroom uh, is wet, it will increase the chance of bad bacteria infection on the mushroom. Okay. So on figure 6, we can see the IoT control unit. So this contain the microcontroller, the relay, okay, right, to control the system, right. Figure 7 shows the exhaust fan, okay, which it will regulate the temperature and humidity. We also have a water pump, right? So exhaust fan and water pump is controlled using a relay, okay. And we also have a mist uh, uh, mist sprayer, which will spray water to the external net, right? So this is also to reduce the temperature, right, of the mushroom house. Right, so let's see the results. Right, so on in figure 10, this is the comparison for the temperature before and after we implement the system. So we can see the average temperature is so so the blue is the before and the orange line is the after. So we can see that after implementing the system able to lower the temperature of the mushroom house without using any labor. So all the process is being done automatically. Okay, right. Same with the humidity. You see, after we have implemented, right, the orange line, be able to maintain the humidity level at the optimal um, range. Okay. Okay, so as a conclusion, we design and implement an automatic IoT-based climate control system for cultivating the oxymoisture in indoor space. So the system is designed for low cost in terms of hardware resources and practicality. So it can be used by any mushroom grower because it is available and very low cost and it is practical as has been demonstrated in this project, right? The proposed system was implemented and tested in a real case study in the National Autism Society of Malaysia, NASOM, in Bandar Puteri. Okay, why we implement the system in National Autism Society of Malaysia? Because they want to use urban farming as a sustainable um, source of income to their autism center. So the profit being made from the mushroom is will be used to support their centers in taking care of autism center or autism people, right? So based on the results, this is to improve the productivity of mushroom farming, especially the labor needed in monitoring and maintaining the mushroom health in the environment requirement. So after we implement this system, so before we implement this at the autism center, the the caretaker of the mushroom house is also a person which taking care of the autism person. So after we implement the system, they doesn't have to do the manual labor. They just only for once a week they go into the mushroom house just to harvest the mushroom. They doesn't need to spray or take care of the mushroom anymore, right? So it's been automate has been we have automate the process, right? So sorry, this is a reference used in this presentation. Right? So thank you very much for listening to me. So you can contact me by using this email. Thank you very much and have a good day. Thank you.